In this video, we will start to discuss in more detail what is our ARIMA model, and also when we should consider use ARIMA model and why ARIMA model is superior than other model we have learned so far. So first of all, the Box-Jenkins or ARIMA model, so the ARIMA stands for Auto-Regression Integrated Moving Average. So for this chapter, we will organize our lecture as following. First, we will discuss in the moving average, and then we're going to discuss in auto-regression, and then we will introducing the integrated part. And then at the end of the this chapter, you will be able to know how we integrating AR, I, and MA together into a one model. So this model is called a Box-Jenkins model. So in order to use ARIMA model, the data has to satisfy certain criterion. So the first criterion is that the data has to be time series data. So it will be very different from the data you saw from like econometrics class or the QBA 3000. So for this model, we are actually only dealing with the time series data. As what we've seen at the beginning of this semester, most of the data we are handling is time series data. So a time series data is a sequence of the numerical observation naturally ordered in times. So the key here is the order of the data is a very important part of the data. So if you go outside to collecting the GPA of your classmate, that is not time series data. So that's the cross-sectional data. So there is no order of your data. So the order of the data will be determined by the time. So the few examples that we are able to consider the data we collected belonging to the time series data are following. First, such as hourly temperature at the entrance at the to Grand Center Central Station. So for this data we collected, so although the data is about temperature, but it will have an order by time. So the other one is the daily closing price of the IBM stock, just like the data you collected for your final project. So this is a time series data because the data has order and is ordered by the time. In a weekly automobile production by the Chevrolet division of the General Motors, so this is also considered as time series data. So again, this is ordered and ordered by time. And then another example is the data from the individual firm, such as daily sales, and yearly profit, daily inventory, daily back orders. So those data can be recorded by daily, and then so it's order data and then order by date. And also an electronic cardiogram. So of course this is order data by time as well. So this is one very important requirement to consider when you can use ARIMA model. So the data itself has to be time series data. In order to define if it is the time series data or not, you just need to understand the data collected. Are they ordered by time? Okay. So when the forecaster examines time series data, two questions are very important to consider. So the first is to consider if do the data exhibit discernible pattern. Are you able to see any pattern in your data, like a trend, seasonality? And the second is, can this pattern be exploited to make a meaningful forecast? So are we seeing any repeats, pattern of the data pattern? So those are the two things we need to consider. So now you can see the similarity of the Box-Jenkins model with what we learned before, the Winters model, because we all care about the pattern of the data, and we all only can use the model to analyzing the time series data, right? So this is the similarity between the Box-Jenkins model and the model we learned before. So this is one consideration of your data. The second consideration of your data is that the data should be recorded at the equidistant time intervals. So you cannot say the data you collected, some of them are daily, some of them are quarterly. So in that situation, you cannot use the Box-Jenkins model, and also you cannot use the West-Winter or the other model we learned before, right? So we need to assure the frequency of the data we collected are equal. So for instance, here I give you a few examples. If you consider a cylinder as the rows across the flat surfaces, So it has to be had the equal distance, right? So you go through when you're rolling the cylinders, so you have to finish one circle, but the time taking you to finish rolling that whole circle is this equal, right? So if you locate a point X on the surface of the cylinder and observe how discrete observation trace a path through time. So this connects you with some physics class, right? So the average value and the turning point in time series and the conditional forecast, you will be able to see that the distance between the first peak and then the second peak, they are actually have the same distance, okay? So two requirements for your data. First has to be time series. Second, the frequency of the data should not be changed, either daily or seconds or monthly or yearly, so that frequency has to be no change. The same requirement we have imposed on the data when we try to use the Winters model and the Holtz model to do the forecasting. So we have the same requirement, right? So that's the similarity between the data requirement. So basically, if you're thinking the model can use the Winters model or Holtz model to analyze, so that data also can be used, the Box-Jenkins model, to analyze it as well. So for the big power for the Box-Jenkins model is that it can match almost any pattern you see in the time series data. It just needs to be time series data with the same frequencies. Okay, so this is the visualization about what I just talked about, rolling the cylindrical. As you can see, the distance between the first peak and the second peak, and the bottom to the second bottom, so they are the same. That's showing our frequency of this turning are exactly the same. So the question is, who are using Box-Jenkins model? Like I said, this model is so versatile to do forecasting for time series data. So pretty much every subject discipline you can think about, if they are dealing with the time series data, they can use our Box-Jenkins model. So here I list a few. So for the expert in the criminology, if they try to study crime rate by day of month, so that would be daily data. So if they try to predict the crime rate, they can use AI Box-Jenkins model without knowing any experimental variables. We will explain why later. And also in the physics, if you try to forecast the position of the light from stars, you can use the Box-Jenkins model. In the geology, if you are trying to forecast in the gas concentration in the Arctic ice cores, and you can use the Box-Jenkins. For the epidemiology, like studying disease, so if they are trying to forecast the occurrence of disease by day of year, so daily data, and we also can use Box-Jenkins model to help them to do forecast. Of course, most of you guys are econ major and business major, you care about business. So in the business, I listed two examples. So if you are trying to forecasting the daily seasonal variation in the telephone use, you definitely can use Box-Jenkins. And also for the daily fluctuation in the stock market, like that's related to our final project, right? So you can use the Box-Jenkins model. Lastly, if you're trying to predicting the growth ring size in trees, you also can use Box-Jenkins. Again, for Box-Jenkins model, you just need to make sure you are assured the data you are analyzing is time series with the same frequency. And then regardless what the kind of pattern they demonstrate, you always can use Box-Jenkins to help you find the best model to forecasting that time series. So it's a very versatile model. So as I mentioned at the previous video, and I mentioned about what we learned in our two chapter ago, we look at the multiple regression causal regression model, and we mentioned in that chapter that the model itself is very powerful. But then we want to do a little bit comparison between these two powerful model, the multiple regression causal analysis versus our Box-Jenkins model or ARIMA model. So what you need to determine when you need to consider use regression analysis or when you need to consider use Box-Jenkins analysis, and how you compare which model is better. Okay, let's see, we are trying to use the model to forecast the firm sales. So without any consideration, we can choose either Box-Jenkins analysis or we can use the regression analysis. However, there is some situation you have to use one versus the other. So if you want to use the regression analysis, the key here is the sequence of the data you observed has to be able to identify some other explanatory variables. And also the other explanatory variables frequency usually has to match the frequency of your predicting variable for firm sales. So if your forecast model try to forecast in firm sale annually, so you need to find other explanatory variables that are also with the frequency as annually, okay? And so here I mentioned about, for instance, you can look at product price, personal income, advertising expenditure, etc. So those information has to be available in order for you to consider user regression analysis. However, if all those explanatory variable is not available, maybe because you don't have the time to collecting it, there's no historical record about those variables value, or those variables value doesn't have the same frequency as as the firm sale frequency you try to predict. In that situation, you should consider try to use the Box-Jenkins model, because for Box-Jenkins model, we will explore later in this chapter, is that we don't need any explanatory variable that is not our firm sales. So the only variable we need is firm sales. And then we just need to make sure the firm sale data is time series and have the same frequency as you're observing the data. So you can predicting daily sales, yearly sale, quarterly sale, and so you just need the time series data. And so we don't need any other explanatory variables. So now at this point, you want to ask me, Dr. J, if I do have explanatory variable available, and should I use regression analysis or Box-Jenkins analysis? So that's into the real world problems. So usually be a practitioner, we try both models, and then to evaluating their MAPE values or the R-square to see which model give us the best outcomes. However, if we know we don't have any explanatory variables, my first choice or the only choice will be Box-Jenkins analysis. Okay, so hopefully this comparison allow you to decide when you work on your final project what kind of model you want to try and which model will give you the best outcome. Okay, next, after we're talking about the data, we need to consider if you are try to determine if you want to use the ARIMA model or not, and whether you want to make a decision between multiple regression model versus the ARIMA. Now we move on to more detail. Besides the data, we have other requirements that limited you to determine whether you should use the ARIMA model or not. So first, you need to consider is when the only feasible and practical approach, like I said, if you don't have any other explanatory variable, you have to use ARIMA model, right? And the second, basically restate what I mentioned, limited of the explanatory variables. So that's when you need to consider ARIMA model. And then you can use ARIMA model as the benchmark model, right? Like I said, if you do have explanatory variables, and so you feel free to try the multiple regression causal models, but at the same time, try the ARIMA to see which one give you the better. So ARIMA always can become your benchmark